You need to know the life cycle of a star. Okay, and here is a rather complicated diagram, but we're going to simplify it and explain it to you. Right, there's a really good video on this. It's done by Professor Brian Cox. I've seen it on YouTube. I think it's called Star Death and Creation of the Elements, and it's on the Wonders of the Universe series by the BBC. So you should have a look at that. This will really help you explain it and makes it a bit more interesting as well. Right, the general shape is like this. At the top you have hydrogen, which was formed at the beginning of the universe when the Big Bang was created. Loads of hydrogen was around. And if you notice, it splits into two main branches, okay? And then the branch on the left-hand side, it represents our sun, okay? And in our sun, elements up to iron are made. If you go to the right-hand side, you can see that it then branches into two again. And these are where elements heavier than iron are made. And if you notice, it splits in half then, because one half will actually end up as a black hole and the other half will end up as a neutron star. So that's the general shape of it. You'll need to know the terms as we go along. Right, this massive cloud of hydrogen and helium can form a gas cloud called a protostar. And all the individual atoms of hydrogen and helium are attracted to each other by gravity. And if they start falling towards each other due to gravitational attraction, eventually, as they fall, they get more kinetic energy, and eventually the pressure builds up as more and more hydrogen falls in there. And the star sparks up for the first time. And that there is known as a main sequence star. Now, at this point here, the temperatures and pressures are so high, roughly around 15 million degrees C in the middle of the star, that hydrogen will start to turn into helium. Now what you've got there is you've got gravity shown by the red arrows pushing the planet in, the star in, and the thermal pressure due to the heating effect of the star is pushing out. Now the forces are balanced, so you need to be aware of that. You don't need to know what thermal pressure is, you just need to know there's forces pulling in and forces pushing out, and those forces are balanced. As a matter of interest, the sun, for example, grows and shrinks by 800 miles a day. It's oscillating backwards and forwards because of these contracting, forces that act against each other. So there you go. In the main sequence star, hydrogen is being converted to helium, which is what our star is doing at the moment. Our star is going to keep on doing that for several billion years, and stars like ours will eventually become a red giant. Our star is expected to eat up, once it's used up a lot of its hydrogen, to begin to start to do helium fusion. That's when helium atoms combine. And it will grow to such an extent that the red giant will eat up Mercury, Venus and Earth, we believe, and stop at Mars. That's how big it's going to get. And the reason it gets big is that in the middle of the red giant is this really very, very hot core where helium fusion is taking place, where helium is making the heavy elements, and it generates such a huge amount of heat that it pushes out the outer layers of the star. And of course, as the star expands, it cools, and so it's no longer the sort of bright yellow colour you see. It's a sort of red colour, but it's a much bigger star. And again, you've got gravity pulling it in and thermal pressure pushing it out. After it's gone through the process of turning helium all the way to the heavier elements, then it'll stop doing fusion, and it'll cool down, and the core in the middle will form something known as a white dwarf. And basically this happens when there's no more light elements left. And the white dwarf is basically a very, very small star, but that's incredibly hot. And as it cools down, it goes from white dwarf, yellow dwarf, orange dwarf, red dwarf, brown dwarf, and eventually ends up as a black dwarf, which is obviously very, very cold. You just need to know the terms main sequence star, red giant, white dwarf and black dwarf. That's where you'll pick the marks up, by mentioning those things there, and by also saying that it's the elements between hydrogen and iron that are formed in this sequence. Now, if we go back to the main sequence star, there are some stars that are actually much bigger than our sun. In fact, our sun's actually quite a small star. And if you have a star that's between 20 to 30 times heavier than the sun, it'll go down a different path. There are stars that are much, much bigger than our suns. We're going to see what happens to them. Right, so there you go. Stars that are much bigger than our sun. Well, when they've used up their hydrogen, they'll form a red supergiant. Now, a red supergiant obviously is the same as a red giant, but obviously a lot bigger. And because the star is much, much bigger and therefore has much higher pressures and much higher temperatures, it tends to use the fuel up, the hydrogen up, a lot quicker. So even though there's a lot more material here, they last for a very short period of time. And when the red supergiant has used up, gone all the way, used up the hydrogen, helium, it's worked all the way down the periodic table, all the way down to iron, at that point it can do no more fusion and the whole thing collapses. And when it collapses, it forms an enormous explosion called a supernova. Okay, a supernova. Now this supernova releases more energy than the rest of the galaxy combined for that short period of time, and it can go one of two ways at this point. Now the supernova then actually causes other atoms to fuse, so elements heavier than iron, things like gold, silver, platinum, uranium, all these heavier elements that are heavier than iron will actually be formed then. So if you've got a piece of gold, that was formed in a supernova. That's a cool thing to know. And if you've got a star that's roughly around 20 times the mass of the Earth, it will form something called a neutron star. And that's made up exclusively of neutrons, nothing else there. And in fact, this is so dense, the neutrons are packed right next to each other, that a teaspoonful of this stuff weighs about 100 million tons, which gives you some idea how dense this stuff is. Now, if you have the neutron star cannot get any more packed. Gravity's pulling it in and the neutrons are sort of knocking against each other. But eventually, if you add more and more matter to it, say you've got something that was originally, say, 30 times the mass of the sun, even the neutrons begin to collapse in on themselves. And then at that point, you end up with a black hole. And a black hole is obviously very famous. Nothing can escape it, not even light. So that's the way that things happen. And black holes exist all over the place. There's one in the middle of our galaxy, for example. There's nothing to be afraid of. They're just sort of at the end of the road for stars. And so that is basically the life cycle of the star. Our star will go down the left-hand side. Lots of other stars will go down the right-hand side. You need to make sure you know all of the terms that have been underlined. Supernova, black hole, neutron star, red supergiant, protostar, red giant, white dwarf and black dwarf. Make sure you know what they are and put them in the right order. And that is today's video.